Hello and welcome back to the third videos of the Pocket series. So last time we left here where I put the BME 688 sensor, um, and then we have connected the I2C pins to the 2040, etc. So since then I have reread the datasheet of the RP 2040, and I have noticed that where I have seen that the SDO doesn't have to be connected to the doesn't have to be connected high, can either be connected high or low. In this case I prefer to be connected low, so I'm just changing that one. So we'll have address 0 for there will be an address allocated if you pull it down low, which I think is 75, and then if you pull it out a high, it will be 76, I believe. So in this case, I'm gonna use I'm gonna pull it low. From here, what I want to do, I want to actually rename these two to BME, as I don't want them to have them confused with the I2C of the LCD screen we are going to install, put soon. So let me rearrange this one a little bit. That's it, and that way should be okay. Also on the pinout of the Pico, I have seen that the GP4 and GP5 are the I2C 0 pin, so I am going to move those there. So looking at the pinout here, I have I2C SDA GP4 and GP5. So GP4 is the SDA and GP5 is the clock. So I'm gonna use those as reference. From here, what we are going to do is we are going to, let me see. I'm just wondering, I'm gonna take this one over here for now, and I'm gonna move this one down here. I'm gonna move that one there. I'm gonna move that one up a bit, and I am going to move this one also up a bit because I will modify slightly that one. So I have moved those, and before I forget and I made any mess, I'm going to rename those BME, because those two pins are the one for the sensor. Right, now what we have I want to put a connector. The connector is, it's a 12 pin. It's like this one basically. It's a mounting pin, so let me check. So connect 01 12 mounting pin. Here we go. I think that is the one. Yes, So I am using that one, and for the footprint, we're gonna use this one here, horizontal, I believe. Yes, correct. And I press OK, so I don't have to mess about with footprint later. So I'm gonna rename this one just for the sake of it, GH125 LCD interface. And that should be okay. Also, while I'm here, I want to use this, the same connector at that one. So I am going to find a 0103 0103 mounting pin. That is the one, and again JST horizontal, and that is what I needed, and I put that one there, and cancel that, and I am going to put those in this way, and I can delete that one. And this one I am going to call it SWDO. And I'm gonna put that one roughly there for now. So I'm gonna use a ground for that and a ground for that. Now to connect the LCD, you need to follow this connection here. So let me see if I can try to do I may need to reduce this side, and I'm going to reduce this side here. No. And we're gonna get that one. Let's have a look. Okay, yeah, we can do that way for now. So pin 1 is 3.3, so we're gonna find 3.3 volts. I think at the moment I still got the ground, so I'm gonna put the ground there, and now I'm gonna copy and paste a 3.3 volts here. So that's what we have there. So those one, they are in order. So pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you just go on, you just use that reference. So now what we have, let's push some lines there. And copy and paste. Copy and paste. Remove those. So what we're gonna do, label, and we call the first one, we're gonna call it LCD DIN, and I'm gonna place it there. Then we're gonna call it LCD clock, and what we're gonna do, we can so we got the clock. Now we do the CS, the DC, and the RST. And the backlight. Now we do TP SDA, TP clock, TP reset, and TP interrupt RQ. And it's okay. Now from here we need to look the I'm gonna copy those, I'm gonna pull it there, and what we're gonna get, I'm gonna get that, I'm gonna rotate it, and I'm gonna put the DIN is gonna be on GPIO 11. So you need to well, basically you replicate this one, GPIO 11. Then we got the clock. The clock is GP10. Clock and GP10. Okay, the LCD CS is a GP9, so GP9 is there, and then we got the DC GP14. GP14 is the DC. Then we have the we have the RST is GP8. The backlight is 15. Then we have the TP SDA is a GP6. Then we got the clock is a 7. Reset 16. And RQ I think is 17. So that is done. Let me move this one back so they are roughly all the same. So now we're done with this one. I can close that and I can just rearrange that one here. So now we have connected the LCD as required by the documentation. What we have left to do is to close all those. Because they are not needed. And what I need to change is actually those, we need them. I need them because here we need to do a create a 1.1 voltage. So what we're going to do, we're going to put that one there. We're going to rename that one 1.1. And what we need to do, we need to connect these two to the voltage. Then we need 3 capacitors, which this one need to be 1 micro and the other 2 can be left as 100 nanofarads. So we can put that one there and we are going to connect that one there and we'll give a ground. That's it. And then these two, quite easy. We position there and we are going to connect that one there, that one there, connect that one there, there, and then we're using a ground. There we go, and we're done. So after we've done that, I want to put a note that let's have a look. Where is note? Text. Place C18 close to pin 45. Place C18 close to pin 45. And I'm going to put that one there. Here I'm going to replace make sure we place same for here. Okay. And that we are good. So let's save it for now in case make some mistakes. I think what I want to add is a push button. If you look the Raspberry Pi. It's another one. It's that one. And then you go to hardware, documentation, microcontroller, Pico. Right. As you can see here, there is this little nice push button which I want to implement into my schematics. At the moment here, I did place a jumper, but the jumper I think is gonna stick out too much, so I'm gonna want to replace that with that push button. So that push button is actually a SKR Pace 0110, I believe. So if you search, let's have a look. So it takes ages. There we go. That is the push button I was looking for, and as you can see, if you select the first line, you get the symbol, the footprint, and the datasheet. You click add to the library. I am not going to overwrite because I have already, but you will be pressing OK. So you've done that, and you be able to have the push button in the library. So we are going to find that one, SKR. There we go. That is the, as you can see here, there is no footprint, so it took me a while to understand where the footprint was. So I am going to show you in a second. So here, what we're going to do this, and we're going to do this, and then we're going to click that one there, and we're going to click that one there, and what we're going to cancel. Let's make all the same, and I am going to add a net label, and I am using the wave symbol. I don't know how that calls. Square curly brackets, and I want to put USB boot, and that will give us the top line. It means that is pull low, so it's active low. So when we press the push button, it will activate the boot process, the USB boot. So you press the button and you plug into the USB, and then you release the button, and you will be into programming mode. Right, I think here I am okay. I think here I am okay. Let's have a look if there is any error. We have one error. What did I forget to plug in symbol J1 and symbol U4. So U4 is this one. Okay, we got an error there. Got an error there, which shouldn't be. And the other one is I had it was only one J1 What's wrong with that one? What's wrong with this? Okay, let me check what we got wrong here. As I cannot see a problem because the ground is linked with a shield as it should be. And this one gives me the power output, yes. Right, why I have this one? Why I have this arrow? Why I have this arrow? Um, okay, let me. Shouldn't make any difference on that one. Power flag. Should need a power flag. Now I have two arrows. Okay. Pins of type power output are pins of the type power output and power output are connected. Yeah. V out. So if I go to the hardware design, and I pull this one back here, because basically that's what actually I'm doing. I'm just replicating this one, because that's what I need. So I'm not really sure why that. Not sure why that does that. So for now, let's try to ignore it, although I don't like it, but we got to do it. Let's assign some footprint, shall we? Let's do something more interesting. Right, so capacitors. I want to use the (0402). Here we go. I'm gonna use them all for the capacitors and same for the resistors. Now resistors, let's go to the resistors, and we have 0402 metric, and I am going to do the same. For the quartz, for the crystal, I have used I3225 3.2 2.5. That one I have used, that's fine. So for this one I'll show you how do we do the footprint for the USB micro. For the USB micro, we're using a Amphenol 3594. That one, we're using that one. That is okay. BME, we haven't got that one, but for the BME it's a LGA 8. Is an LGA 8 3x3 pitch 0.8 clockwise pin numbering is that one. That is done. and then for this one is actually for this one is actually a salted 223 SCOT 223. And we can see it, and it looks okay. And for the RP, we have let's have a look. What do we have here? We have a DFN QFN 56. What I am not sure on here now is why I have got thermal views. Okay, it looks like this one here. Let me check though if there is the sizes. That could be actually in the data sheet. So let's go back to the data sheet, and pin location is a QNF 7.7 times 7 by 7. It's a 7 by 7, so that's what I am going to use, a 7 by 7 thermal VS. Use that one for that one, apply, and then that one I'll show you how we do that one. So to do that one, we go to the double click on the icon, we go to the footprint, and here we are going to look for a folder called KiCad, which is there. Open that one, and then you select the symbol there. Now we should have all the symbols as needed. So from here we're gonna save it, and we're gonna open Fusion, where we have kind of planned the case. I am removing those which I have created myself. They are not needed. Basically, this is the component which Waveshare allow you to use. Is on their website, so you can download it and then import it into the Fusion. So from here, what basically I have done some sketches. I've done a sketch based on the outer edge and the inner edge, and then I have extruded that sketch to create a box. And then from the sketch, as you may have seen earlier, I have also extruded the house, the two circle a little bit, just to give the clearance from the components underneath, and then a little bit just a notch to snap inside the PC board. So from here, what I want? I want to actually have a sketch. I have created a sketch of the blue PC board, and then I can use that. If I remove now that one, I can use that as a reference for my edges in KiCad. So once you have created the sketch you want, what you do, you right click on the sketch you want to export, and then you click export the DXF. You give them a name, PCB for example, and then you tell it where to export it. I already chose mine, where I want to export it, and then you click save. It will say, do you want to overwrite it? Let's say yes, and you should have the edge cuts line exported. So I'm done with that one, so I close that one down, and now let's see if we can actually if you can create the PCB. So you go back to your main KiCad software, and then you press PCB, and then here you normally, when you start, you have FCU selected. The first things I want to do, I want to use 4 layers, because I think it's going to make our life slightly easier. So you go to board setup. Let me show you again. You go to board setup here, you click it, you go to physical stack up menu, and you change this one, the copper layer, and that's what you need to do. And then you will see you go the front, inner 2 and back. So from here you need to use the edge cut. The edge cut is the layer where the manufacturing software will determine what shape of board you have. So you select that, and then you go to file, and you import a graphic. You import the graphic, and I already selected the one I saved it, so you need to go to your folder, and then you click OK, and from here then you place that one wherever you like it, to be honest. So if all gone well, if you press the 3D button here, we should be able to see the shape of the 3D of the board. So that worked. So I'll save it just in case it crashes, and then what I'm doing from now is update the PCB from schematic. So I click that and update it. Okay, what's happened here? We got some errors. We got U3 errors, so let's close that. Let's put those one there for now. U3, we have a U3 problem. So the U3 is this one. Okay, did I not put the U3 there? Probably I haven't put the U3. I haven't put that one out. So let's go and do a I think it's a SOIC 8. SOIC 8, and then is a 5.3 by 5.3. 5.3 by 5.3, and the pitch is 127, so that should be the right one. Yes, and I click on that one, apply. Okay, let's save again, reduce that one. And what I'm going to do now, I am going to update it again, and that's done. There's no errors, and we should have U3 here. Perfect. So now what we're gonna do, we're gonna move, if you move everything here, for example, just now as an example, you will see it populate your board. Of course, this is not the way we want our board populated, so we need to do some work in here. So let's go back where they were, and we will start to populate the board on the next video. I don't want to expose all and I don't want to do a very long video, so I'm gonna split this one in two. So far what we've done, we have created then we have finished the schematic. We have adapted some, we have changed something from the second video I did, but we added a LCD display connector, and then we have connected those pins to the right pins on the 2040. Also, we have assigned all the footprint. As you can see, there is no yellow highlighted, anyone highlighted in yellow, so that means we should be all, they were all good. From here, then what we have done, we have exported a sketch which I created to replicate the back of the screen. Basically, we replicated the edges of this blue screen here, and we done the sketch. So the sketch then has been exported. You right click, and then it's been exported as a DXF. And then once we've done that, we have opened up the PCB board section of the KiCad. We have changed the settings from 2 layers to 4, and then we have them here. We have selected edge cut, and we have imported the graphic, which is this one here. After imported that, we have checked if the shape was recognized, and it does. And then we then updated the PCB from schematic, and that we will have imported all the components needed. So on the next video, we're gonna start to position all those components in a way that should be okay, and and then we'll start to do the routing as well. So I will end the video here. If you want to see a video on how I have created the case for this little project, like this one here, I hope you don't need, no, I hope, probably you know already how to do it, but if you want me to show you the process of how I did it, just leave it in the comments below and I'll do a video just for that one. So as always, if you haven't subscribed to the channel, please do so. That will help me immensely. And then we'll see you on the next video. Thank you for watching. Bye bye.